Hello everyone, and welcome. Today, we're diving into a key concept in a common lab technique. We'll be exploring gel filtration chromatography, which is a method used to separate molecules based on their size. To properly analyze the results from this technique, we need to understand a very important parameter called KAV. So, what is KAV and why does it matter? Let's get right into it. KAV, spelled KAV, is the partition coefficient. It's a calculated value that describes how a specific molecule is distributed between the stationary phase, which are the porous beads in the column, and the mobile phase, which is the buffer flowing through it. In simpler terms, KAV tells us what fraction of the pores inside the beads is accessible to our molecule. We calculate it using the formula, KAV equals V/V2 Now, let's break down what each of these terms means. First, we have V, which is the elution volume. This is the volume of buffer required to carry a specific molecule from the top of the column to the bottom where it is detected. Different sized molecules will have different elution volumes. Next is VO, the void volume. This is the volume of the mobile phase that is outside the porous beads. It's the space between all the particles. A very large molecule that is completely excluded from the beads will travel only through the space and elute at the void volume. Finally, there is VT, the total volume. This is the total volume of the packed column bed, which includes the volume of the beads themselves plus the void volume. Understanding these components helps us interpret the KAV value. If a molecule is very large, it cannot enter any of the pores in the beads. Its elution volume, V, will be the same as the void volume, VO. When we plug this into the formula, we get a KAV value of 0. This means the molecule had access to none of the internal pore volume. On the opposite end, a very small molecule can freely access all the pores within all the beads. It takes the longest, most complex path through the column. This results in a KAV value of 1, meaning it had access to 100% of the accessible internal volume. Most molecules of interest will have a KAV value somewhere between 0 and 1. The closer the value is to 0, the larger the molecule. The closer the value is to 1, the smaller the molecule. The main reason KAV is so useful is that it normalizes the elution data, making it independent of the column's specific size or how it was packed. This allows scientists to compare results across different experiments and different columns. It is also essential for creating a calibration curve to estimate the molecular weight of an unknown sample. Thank you so much for watching. If you found this explanation helpful, please give this video a thumbs up and subscribe to the channel for more science content. Don't forget to hit that notification bell so you won't miss our next video. Your support truly helps us create more educational content like this. See you next time.